So in today's lecture we will be discussing relays and functional characteristics, and we all know that the relays are integrated part of the protection system switchgear. So here we will be discussing what are the basic definition of the relay and what are the basic functional characteristics of the relay. The basic definition of the relay is it is an electrical relay which closes its contacts when an actuating quantity reaches to a certain preset value. So due to closing of these contacts, the relay sends tripping signal to the circuit breaker and alarm. So maybe the actuating quantity can be electrical type and it can be non-electrical type. So electrical type actuating quantities are the current, and the example is over current relay, over voltage relay, and there are some non-electrical quantities are also which is comes under your syllabus, that is Bucose relay, which is actuated with the gas. So this is the only relay which we will study which is having actuating quantity other than electrical current and electrical voltage. Now the important part is the relay time. So the relay time is nothing but the time between the instant of fault when there is a fault occurrence of the fault and the instant of closure of relay contacts. Like breaker time is also known as the time between the instant of CB operates and it opens the contacts to the instant of arc extinguishing. So if I define the fault time, fault clearing time, it is the time taken by the relay to anticipate and the time taken by the circuit breaker to operate on over the instruction of the relay. So this is how this fault clearing time can be defined. So in this slide I will be discussing the pickup values. So if you remember the minimum value of the actuating quantity which relay start operating, that means suppose I set the value of the actuating quantity is equal to 4 and there is a substantial increment in the current which is higher than 4 ampere, then the relay will be operating, and this particular quantity pickup is known as the this 4 ampere over which if the value of the current is beyond that, then the relay will operate. So this minimum value of this actuating quantity is known as the pickup. Now the dropout or reset is nothing but a relay is set to drop out or reset when it comes back to its original position. So when there is a fault, that means if there is a fault, the relay contacts are actually closed due to high current, and then it will come back to the original position because the value of the current is reduced. So in university examination you will be able to find this question, that draw a neat sketch of circuit breaker, trip circuit and relay circuit and explain each function of this. So in this example I am showing a bus bar which is a charged conductor, a pair of circuit breaker and relay which are interconnected with each other, and there is a measurement of the current which is done by the current transformer, and the current transformer is attached with the relay coil. So what happens when there is a fault in the system, the value of the current is higher and this high current will attract the relay contact and this trip circuit is closed, and there will be a DC current charging of this trip coil is done, and this circuit breaker is shifted to back. So the main part of the circuit is isolated with the help of this mechanism. So it is very important that the setting of the relay and this force which is required to close the circuit is actually nothing but the value of the pickup of the value of the pickup of the current. So if the value of current is lower than pickup value, then there will be no such certain amount of force which can close the contact of the relay circuit, trip circuit. So if it is not there, then these relay will be not operating. So this is highly conventional circuit which is consisting of this relay contacts and the CT. Now again there will be a fault and there will be the mechanism, as I show you that over here this is a certain force which is actually dropping it down, this spindle down, and then the circuit breaker is opened. So this is very important part. Now we will talk about the functional characteristic of the relay. So the functional characteristic comes under this reliability. Reliability is also a very important functional characteristic of the relay. That means, suppose I have assigned a relay to act in a fault zone. So suppose if I take example, so this is a generator and there is a transformer and there is a bus bar, and let me say this is the unit of bus bar, and there are relays and there are CB assemblies are attached with it. So this is R1, this is R2, this is R3, and this is R4. So whenever there is a fault in the system, so suppose here motor is connected. So this is a single machine the system which is connected to a load, and there is a fault in the system. So what is happening to this? The reliability of the relay depends upon that the ability of the relay system to operate under the predetermined condition. So what I want to do, that R1 should operate and R2 should also operate when R1 fails to do that. So by R1 I am providing main protection, and by R2 I will be providing backup protection. Okay. So the reliability of the protection system depends on couple of things, like you can say it is reliability. Reliability is the function of every equipment like reliability of the system, protection system depend upon every equipment like circuit breakers, relays, current transformers, and potential transformer, PTs. Also, it is important that for increasing the reliability, what we require periodical maintenance. System the inherent reliability also can be achieved with simplicity, high contact pressure, good contact material, good workmanship, dust-free environment, like this. So the reliability of the relay is a basic functional characteristic which is required when we are going for designing a protection scheme. Also, the system reliability depends upon the reliability of the circuit breaker, reliability of the relays, CTs and PTs. Periodical maintenance and timely maintenance also enhances the reliability of the relay and the protection system. So this is how the question comes in the RTU, that in any university examination or midterm examination, explain functional characteristics of the relay. So reliability is the first functional characteristic of the relay. Now the second functional characteristic of the relay is the selectivity and the discrimination. So these are two different things. So first we discuss selectivity. So selectivity is the ability of the protective system to identify the faulty part correctly and disconnect that part without affecting the healthy part. So if I take the previous example like this, so this is how a system is having two transmission lines, and it is connected with the pair of relay and circuit breakers, and there is a load over here. Suppose there is a fault in the system and it occurs on T1, and T2, transmission line 1 and transmission line 2. So what this protection system R1 and R2 will do, this R1 and R2 will disconnect this line. So finally after fault the system will look like this. So there will be a generator and there will be a transformer and then there will be a line and there is a load and the remaining line is cut. So this is cut. So this is R3 and R4. So the power will be transferred from through R3, R4 and T2. So this is the act of protection system where it is selective. It is showcasing the selectiveness or selectivity to identify faulty part. So what is this? This is selectivity for identification of faulty part. The discrimination is means to distinguish between. The discrimination quality of the protected system is ability to distinguish between the normal and abnormal condition. So this is how selectivity is done. That means in order to disconnect some part from the power system, we need to be very precise and we need to be selective. Now discrimination is what? Discrimination is the ability to discriminate between fault and normal conditions. So I give you an example. Suppose there is a generator swing. Let me say this is the rotor angle of the generator and this is time t. So there is a local swing and this is due to load variation. This is due to load variation. So what this is not fault, but it is due to load variation. So what I am expecting from the relay, that this part should be discriminated properly. And if I take another example, that there is a fault in the system, that means the value of omega is actually behaving like this, and this is a small signal disturbance which is occurring. So this is here the relay should operate and here in this case for small load variations the relay should not operate. So this is how the discrimination is all about. Now we talk about the speed and time of the protection system. So what happens when a protection system, we are designing a protection system and there are perpetual faults in it. So what we can say, that the speed and time is a crucial characteristic, functional characteristic of the relay. So we require that this fault should be removed, and the attribute of the system is it should be like that the devices carrying fault currents should not be damaged, and the failure of the system to reduction in system voltage, such low voltage also affect the motors and generators running on the customer side, and if fault persists for long time, then subsequently other faults may also be there. So fault clearing time should be very small. Fault clearing time should be very optimal. That means it should be very less. We want that fault should be cleared as soon as the protection system is appearing in the getting in the action. The fault should clear immediately. Okay. And then the second part is it should have clear discrimination between primary and backup protection. Also, it is also necessary to prevent unnecessary operation of the relay under the conditions such as transient and starting inrush current. So, this fault clearing time should be very low, and the speed of the protection system, speed of switch gear for anticipating fault should be very high. So, if I take an example like this, there is a generator and there is another generator, and these bus bars are connected with the load, and this is also there is a load in the system, and there is a fault in this system. And suppose this transmission lines are not cut within a stipulated time, and the protection system is failed over here, then what happened to this G2 is also affected, and it will be this whole part will be suffering from the fault. So, the ultimately it results in the discomfort of the consumer, and there will be power cut. So, these things we don't want. So, what is required, that timely these relays should be operated, and the speed of the protection system is also good. So, what is speed and time? These two are different characteristics. So, the circuit breaker time, it also should be less. The relay time, anticipation time, it should also be less, and the fault clearing time, it should also be less. So, the fault clearing time should be as small as possible to have high speed operation of the protective system. So, this is how we define the speed and time. Now, the important characteristic which is known as functional characteristic, which is known as sensitivity. So, this sensitivity is defined by a formula which is known as Is divided by I naught. So, this Is is what? Is is the minimum short circuit current in the zone. Minimum short circuit current in zone, and this I naught is what? This I naught is minimum operating current for the protection. So, let us take an example. I take a feeder transmission line feeder, and let us see how this is sensitive. So, this relay R1 is mounted over here, and let me say there is a fault current, maybe it is a fault current of 400 ampere over here, and this relay setting is almost let us assume that the secondary of the relay is reading 5 ampere. Okay. Now, the fault current is 400 ampere, and if I say this is 400 ampere and there is a CT of 5 by 400, 400 by 5, CT ratio is 400 by 5. So, the secondary of the CT will read current 5 ampere like this. So, this relay is 5 ampere, and this is 400 ampere fault current. The normal operating current, let us assume this normal operating current is 300 ampere. So, accordingly the relay will be having this value like 300 into 5 by 400. So, this is 0.75 into 5. So, this will be 3.75 ampere. So, let us assume that this pickup value of the relay is 4 ampere, and there is a fault of 400, fault current is 400 ampere. So, the minimum short circuit current in zone is, let us assume this is the minimum short circuit current is 400 ampere, and if I assume that different event, so this event E1 400 ampere current was there, like En there was 450 ampere current was there. So, there are n number of events, but the minimum current is 400 ampere. Okay. And the minimum value where the relay will be picking up, it is 4 ampere. So, if I take case for this, so minimum short circuit current in zone, this is 400 ampere. Minimum operating current for the protection in the relay, this will be equal to 4 ampere like this. So, if I read the primary current, it will be 4 ampere, so it will be equal to this will if I calculate it with respect to the primary current, so this is 400 by 400, it is equal to 1. It is respect to the secondary current. Now if I change these values, if I change these values, like if I increase this 400 and if I put the value of this 400 divided by 4.5, then what will be meaning of this? The meaning of this, that it indicates that the smallest value of the actuating quantity at which the protection starts operation in relation with the minimum value of the fault current in the protective zone. That means if this value is high, that means the minimum short circuit current in zone is, and the ratio, the difference between these two quantities are higher, like this. So the relay should not be very sensitive and relay should not be very insensitive also. So there will be a balance between sensitive element, sensitive and insensitive. So there should be a balance and it should be according to tailor-made. This should be tailor-made and it should be derived from the conditions, operating conditions, circuit conditions. Now we will talk about the stability. The stability of the relay is nothing but the quality of the protection system, due to which the system remains inoperative and stable under certain specified conditions, such as transient disturbance. So if there is a transient, that means a sudden change in the value of the current. So this is not the fault, this is a system transient. So in this case, the relay should not operate and it should be stable in such conditions. So certain modifications are required in the system design in order to combat these things. So in most of the cases, the relays are provided with time delays, filter circuit and mechanical and electrical bias. Now we again discuss this adequateness. Adequateness of the relay is let me say that if I talk about the faults, so there are multiple types of faults, like there is a single phase fault, there is double phase fault, there is double phase to ground fault, there is 3 phase to ground fault, there is open conductor fault. All these faults are actually occur on the relay and all are subjected to different fault MVA. Different fault MVA will be there for all these faults, as well as the affecting phases are also different. So there may be a phase A, phase B, phase C, and the faults are occurring in different parts. So the point is you need to be very clear about the adequateness. That means the relay should operate for all these faults and there should not be any misoperation during this fault. So it is also very important that rating of various equipments, cost of the equipment, location of the equipment, probability of abnormal condition due to internal and external causes, discontinuity of supply due to the failure of the equipment, all these things are actually comes under this. So that means that the relay should be robust enough to operate under these fault conditions. Now the third one is the relay design should be simple and economically feasible. So in addition to all important quality, it is necessary that the cost of the system should be well within limits. Economic considerations, that means our protection system is not very much costly. So when I talk about two type of protection system, one is the static protection system, which is microprocessor based system. Another one is the conventional electromechanical system. So if I talk about this EC and this ES, the economic consideration, so this is more greater than this. ES is greater than ES. That means the economic considerations are violated in the static protection, because these are microprocessor based relay and often the cost of these relays are very much higher than the conventional relay. So still in our Indian grid we are using conventional relay, which are electromechanical relays, but with the evolution of the smart grid, we are making the protection scheme microcontroller based relays. We are doing microcontroller based relay, which are self-adaptive in some nature. This can record the memory. These are having no memory. So these static relays are having memory and anticipation, better anticipation, and the speed of this protection system is very high as compared to these. The maintenance required in these systems are low, but here in this case maintenance are required. Other thing also come with this, that the static protection require an auxiliary supply. On the other hand, these systems are not conventional systems are not having not required any kind of auxiliary supply. So there are some certain benefits, certain pros and cons are associated with each method. So these are all about the functional characteristics of the relay. So in your examination, two questions may be asked. First question is to devise this system which is having one relay, one CT and the trip circuit, and the second is to describe the functional characteristics of the relay.